Hey everyone, happy Thursday. So today we're going to keep going with properties of exponents, but we're going to jump right into our warm-up here. So again, if you haven't tried it, go ahead and pause the video, take a minute, try it on your own, and when you're ready, go ahead and play. All right, so for the warm-up, I asked you guys to graph 3x minus 2y equals -2. That is the equation of a line, but it is in standard form. We have to turn it into y equals mx plus b. So what we should have done first is always, you want to kick over that x, you want to get that y by itself. So we subtract 3x from both sides, minus 3x, minus 3x. The 3x's on the left will cancel each other out. And then be careful here, make sure you bring down a -2y is equal to, now you cannot subtract, you cannot subtract -2 with that -3x because those are not like terms. The -3 has an x next to it, so we're going to go ahead and just write them next to each other. I'm going to bring down the -3x first and then the -2. All right, at this point, I still have that -2 sitting out in front. How do I get rid of it? Well, it says right now -2 times y. So what's the inverse of multiplying? It is going to be to divide. So we're going to divide every single thing here by -2, by -2, by -2. All right, -2's will cancel each other out. That just gives us 1y. Y is equal to, now take a look at this fraction. I can't divide 3 by 2 very nicely. It'd give you a decimal, 1.5. But I can work with the signs here. What's a negative divided by negative? That's a positive. I would rather turn that whole fraction into a positive fraction instead of dealing with those negatives. I'm going to go ahead and bring down my x. And then one more time here, what is -2 divided by -2? A negative divided by a negative is a positive. 2 divided by 2 is 1. This is good to go now. This is in what we call slope-intercept form. Y equals mx plus b. Now again, I don't give you guys graph papers, so again, it's not going to be the prettiest graph in the world, but we can get away with it just to give a rough sketch. So you should have created your coordinate plane, something along these lines. And again, it's not the most straight, perfect thing in the world. It's okay. We'll get the idea here in a minute when we graph it. Okay, so where do we begin to graph when we have something in slope-intercept form? We begin here at the very end, at the end here. This is your b. This is called your y-intercept. So that's where it's crossing your y-axis. You should have gone up one space, and that is going to be 0, 1. That is our y-intercept. It's sitting at 0, 1. Great. How do I get the rest of the points? Well, we have to use our slope. Now, this is a +3, so that is going to tell me to go up 3 spaces, and that's a +2, so I'm going to go to the right 2. So if I climb up 1, 2, 3, and then to the right 2, careful when you're counting here, that's going to give me my second point. And I'm going to go ahead and erase that bunny hop. It looks a little tacky. So I'm going to go back in there and erase it. I could go up another 3 and right 2, and I can also reverse both of these. I can go down 1, 2, 3, and to the left 2. Notice where I put that third point, they still all line up nicely because, again, this should be a line. We're graphing a linear equation, so just go ahead and connect that, and there you have it. That is the equation y equals 3 over 2x plus 1. All right, so let's go ahead and jump into today's work. So we're still going to continue talking about properties of exponents. So far, guys, we've talked about product of powers. So product of powers, remember, it means is if you're ever multiplying and you have the same base, something like x, and you're dealing with exponents here, I'll put a 5 and a 7. The shortcut says you can simply go ahead and add those. 5 plus 7 here would give us x to the 12th. Okay, that was product of powers. That's one of the shortcuts, one of the properties that we've learned. The second one that we've learned is power to a power, something that looks like this, where you have a base, something like an x, to the third power, and then even that has an exponent on top of that. So what do we do when we have a power to a power? We go ahead and we multiply those. 3 times 2 would give us 6. That is x to the 6th power. Today, we are going to talk about what happens if we are dividing. So, right, take a look at the first one that we did here. When we're multiplying, we add our exponents. What might happen when we're dividing? Or what happens when you have a 0 exponent or even a negative? We actually don't like to have negative exponents in math, so I'll show you guys how to fix those. All right, let's move on here. All right, so here's a quick little summary, guys, of what we've done so far. Right, one more time, there's product of powers, and there's power of a power, power to a power. If you wanted to see those examples one more time. And again, the ones we're going to deal with today are negative exponents, 0 exponents, and quotient of powers. Quotient is just a fancy way to say divide, right? Like product was a fancy way to say multiply. Quotient is just a fancy way to say divide. All right, so real quick before we even jump into it, why can I simplify the following by 3? So if you ever have a fraction, something like 6/9, and I ask you guys to simplify it, you've probably seen this in the past, right? We'll do this. We'll divide the top by 3. We'll divide the bottom by 3. And then this will give us 6 divided by 3 is 2. 9 divided by 3 is 3, right? That's the simplified fraction. So why are we actually allowed to do that? So the reason we're allowed to do that is, let me rewrite that problem one more time. 6/9. You can actually rewrite 6 as a product of two numbers. Two numbers that multiply to give you 6 are the number 3 times the number 2, right? 3 times 2 is 6. All I did is I rewrote the 6, but I broke it apart. That still says 6. It's just split apart 3 times 2. We know that 3 times 2 is 6. We can do the same thing with the denominator. What two numbers multiply to give us 9? Well, that's 3 times 3. 3 times 3 is the same thing as 9. They're saying the same thing, just that 3 times 3 is actually broken apart. It's split apart. Now, if we just focus here at the very beginning, what is 3 divided by 3? 3 divided by 3 is a secret. See if I can kind of write that in here. This is actually a 1. 3 divided by 3 will give us 1. And if we actually multiply, what's 1 times 2? That's just 2. What's 1 times 3? That's just 3. So you're able to divide top and bottom by 3 because they will cancel each other out. 3 divided by 3 is just 1. So we can kind of eliminate that, get rid of that to simplify our fraction. We're going to use that same idea here, that if you ever have that same number being divided by the same number, right? If you have something like 5 divided by 5, that will always give you 1. If you have 6 divided by 6, that will also give you 1, right? Even if you have variables, x divided by x, what's an x divided by x? It will give you 1. Anything divided by itself is going to be just 1. All right, so let's see if you guys can figure out the pattern. This shortcut here is called Quotient of Powers. Nobody wants to do this expanded form. I'll show you guys kind of the long, tedious way. It's annoying. But again, quotient is just a fancy way to say divide. So I'll actually write that up there. So divide. So what happens if we're dividing and we're dealing with exponents, with powers? So let's see if you guys can spot the pattern. So take a look at the first problem here. It says 2 to the 5th power divided by 2 to the 3rd. Well, 2 to the 5th power, I can actually expand that out. That means 2 times 2 times 2 times 2 times 2, 5 times. And I'm going to do the same thing with my denominator. 2 to the 3rd power, that means 2 times 2 times 2, 3 times. All right, now notice, once we've expanded it, both of these things are saying the exact same thing. One of them is just the expanded form. We stretched it out, broke it apart into its smaller pieces. Now what we're going to do with this expanded form is go through and eliminate. Take a look here. What is 2 divided by 2? 2 divided by 2 is secretly a 1. This is pretty much just going to kind of go away. Same thing with the next pair of 2's here that we see. 2 divided by 2 is just going to be 1. It pretty much just goes away, and turns into 1. Same thing with the next set of 2's here that we hear. 2 divided by 2 is also going to give us a 1. All of these ended up going away. So now what are we left with? 2 times 2, or what's another way to put that together? Well, that's just 2 to the 2nd power. If I want to rewrite this, 2 times 2, I can say 2 to the 2nd power. So I want to see if you guys can figure out how to jump from here straight into the simplified form. There is a shortcut so that you can kind of avoid having to go through all this tedious work. Let's keep going with the next one here. 5 to the 8th power. That means 5 times 5 times 5 times 5 times 5 times 5 times 5, 8 times 1, 2, 3, 4, 5, 6, 7. I almost lost track there. 8. So we have 8 5s, and then 5 to the 5th power. That means 5 times 5 times 5 times 5 times. See how annoying this is? 5 times. All right, now let's go through and simplify that expanded form, right? We know that, hey, 5 divided by 5 is just 1. 5 divided by 5 is just 1. 5 divided by 5 is just 1. 5 divided by 5 is 1. 5 divided by 5 is 1. What are we really left with? We're left with 5 times 5 times 5 3 times, or in other words, 5 to the 3rd power. There's 3 5s being multiplied at the very end altogether. All right, so again, one more time, see if you can figure out how to jump from here to here without having to expand it all out. Let's do this 2 more times here. All right, a to the 3rd power. That means a times a times a 3 times. What about the bottom one? Well, that's just a, right? There's really a 1 there. It looks tacky if we write it. So, I mean, it's just going to be a. And same thing. Let's go ahead and simplify. What's a divided by a? That's just 1. It goes away. So how many a's are we left with? 2. A times a is just a to the second. So I hope you guys have caught on by this point. The shortcut, if you haven't realized, if you're ever dividing and you're dealing with exponents and you have that same base, right, like 2 and 2, 5 and 5, a and a, you can simply just subtract it. Take a look. What's 5 minus 3? That gives you 2. 2 to the second power. The base stays the same. You're just subtracting the exponents, the top one minus the bottom one. Take a look at the next one. 5 to the 8th divided by 5 to the 3rd. The base is going to stay the same. 5 is going to stay the same. But what is 8 minus 5? 8 minus 5 is going to give us 3. Same thing with the next one. What is 3 minus the 1 here? 3 minus 1 is 2. So I want to avoid all of this work and I want to go straight into my answer. I'm dividing here and I have the same base, x and x. So what do I do with those exponents? I go ahead and I subtract them. What is 7 minus 3? That is going to give us 4, x to the 4th power. So that is your shortcut right there. That is your new property of exponents. This is what we call quotient of powers. If you are ever dividing and you have the same base, careful here, it has to be the same base, right? X's with X's, Y's with Y's. You cannot mix and match. You're going to go ahead and subtract the top exponent minus the bottom one. So let me give you guys another example. X to the 10th divided by x to the 4th. We have the same base, x and x. We are dividing, so all I'm going to do is I'm going to go ahead and subtract those. What is 10 minus 4? Right, it's the top one minus the bottom one. 10 minus 4 gives us 6. This is going to be x to the 6th power. Why would you want to learn this shortcut, this property, this quotient of powers? And again, let me exaggerate this. Let me make this super ridiculous. X to the 100, 100 divided by, let's say, x to the 75th power. Nobody wants to sit here and expand that. I'm not going to make anybody sit here and put x times x times x times x times x 100 times and then go through it and cancel. What I can do is I can just, again, if I realize that I'm dividing, I realize that I have the same base, x and x, I can go ahead and subtract the top exponent, 100, minus the bottom exponent, 75, which would give me 25. This is going to be x, the base stays the same, x to the 25th power. So there you have it, guys. That's your new shortcut. That's your new property of exponents, what we call quotient. We want to be bougie. This is a fancy way to say divide. Quotient of powers. All right, so what I want you guys to do is pause the video here and then try these out. Try these out. When you're ready to see the solutions, go ahead and hit play. All right, so for the solutions, for the first one, again, I realize that we are dividing. Well, let me find a different color that kind of stands out a little bit more for you guys. So again, we realize that we are dividing. Do we have the same base? Yeah, x and x. So what does quotient of power say? We are going to go ahead and subtract the top exponent minus the bottom one. What is 12 minus 4? That is going to give us 8. This is going to be x to the 8th power. And again, you could sit here and expand it and cancel it out if you want. You are more than welcome to. For the next one, same thing. You are dividing. Taking the quotient here, you have the same base, k and k. So again, quotient of power says we can subtract those exponents. And again, be careful, it's the top minus the bottom. All right, so 6 minus 8, and here, careful, this actually gives us -2. This is going to be k to the -2nd power. And remember, at the very beginning of this video, I told you guys that we hate negative exponents. As of right now, it's okay. It's okay. You can leave it like that. In a couple of minutes, I'll show you guys how do you actually fix a negative exponent. All right. It's not too crazy. You just have to kind of change where it sits. All right. The following here, guys. It's basically 2 problems in one. So if you take a look at problem number 3, we have n to the 5th, n to the 6th divided by n to the 3rd, m to the 5th. If I go ahead and I was to block this out, let me block out the m's and let me just focus on the letter n here. If I cover up that second part of the problem and I just focus with the same letter, right, the same variable here, n and n, same bases, doesn't this look just like problem number 1, just like problem number 2? Absolutely, it does, it does. Again, we are dividing. We have the same bases, n and n. What can we do with those exponents? Go ahead and subtract those. What is 5 minus 3? The top minus the bottom one, that's going to give us 2. this is going to be, and you're just going to go ahead and write it all straight out, n to the second power. All right, now guess what we're going to do? We're going to cover up the first half of our problem and deal with the second half. So let me find a different color here. Let's cover up the n's and focus on the same variable. Let's focus on that same base now. Good. Doesn't that look exactly like problem number one? It's two mini problems in one. So again, we're dividing. Quotient of power says if I'm dividing and I have the same base, m and m, I can subtract the top exponent minus the bottom one. 6 minus 5 gives me 1. We're going to write this as m to the first power. That looks a little tacky. You could leave it on there. The more appropriate way would be just to write m. But I'll go ahead and write it on there just so we can kind of be sure that, hey, our person grading this understands that that's m to the first power. All right, for the next one, very same idea. Focus on the same bases. Let's focus here on the f's first, right? I have same base. We are dividing. Quotient of power says we're going to take the top minus the bottom exponent. 3 minus 6 is going to give us -3. Careful on this one. This is f to the negative third power. And then we're going to focus now on the second part of this problem. We're going to focus on the letter g. Okay, so take a look. We still have the same base, g and g. We're dividing. We're going to go ahead and subtract the top exponent, 10, minus the bottom one. 10 minus 8 gives you 2. This is now going to be g to the second power, and we're going to go ahead and box that in. And again, yes, I realize we ended up with the negative exponent, and again, in a couple minutes, I will show you guys how to fix those negative exponents. As of right now, that is okay. All right, so negative and zero exponents. I want you guys to see if you can spot the pattern with this. And I know there's two. I want to keep this video pretty short, so you guys have plenty of time to practice. So I'm not going to do that second part here, but let's just focus on the first one. Take a look. The original here says 2 to the fifth power. If I expand that, that means 2 times 2 times 2 times 2 times 2, 5 times. Okay, 2 to the fourth power, the next line here, that's 2 times 2 times 2 times 2, 4 times. The next line, 2 to the third power, that means 2 times 2 times 2, 3 times. What's 2 to the second power? That means we have just 2 times 2. What about 2 to the first power? Well, that's just 1, 2. You only have 1, 2. I'm like, okay, great. So then what's the next one here? How does that work? Well, let's actually multiply. Let's actually multiply these lines out and see if we can figure out what's happening. So let's jump back up to the very first line. If I was to multiply all this out, 2 times 2 times 2 times 2 times 2, 5 times. Well, 2 times 2 is 4. 4 times 1 more 2 is 8. 8 times 1 more 2 is 16. 16 times 1 more 2 is 32. If you actually multiply those out, you'll end up with 32. Let's do the same thing with the next line. 2 times 2 times 2 times 2, 4 times is actually going to be 16. The next line, what's 2 times 2 times 2, 3 times? 2 times 2 is 4. 4 times 2 is 8. All right. The next line, 2 times 2 is just 4. And then the next line here, well, that's just a 2. So what is happening every single time that I'm scooting down? What is happening every single time that we're scooting down? Well, how do we go from 32 to 16? You're actually dividing by 2. How do you go from 16 to 8? You're dividing by 2. How do you go from 8 to 4? You're dividing by 2. Every time we're scooting down here, we are dividing. We're essentially taking away multiplying by a 2. We're dividing by a 2. So if I keep that pattern going, what is 2 divided by 2? 2 divided by 2 is actually going to be 1. And that's kind of the interesting cool part about zero exponents. Anything to the zero exponent, it doesn't matter. It could be 2, 3, 4, 5, 100 to the 0 power. It's actually always going to be 1. It will always be 1. You just have to be careful and make sure you understand who does that 0 actually belong to. And I'll show you guys a couple of examples here in a minute. Let's keep that pattern going though. If that's 1, so if this is 1, how do I get to the next line? Well, what's 1 divided by 2? Well, that's 1 over 2. That is a fraction. And if you keep that going, you keep dividing by 2 every single step of the way down, this would be 1 over 4. The next one would be 1 over 8. Essentially, what's happening is those fractions are getting flipped. Take a look right here. 1/2. Over here, we had 2. Here we have 1/4. Over here we have 4. Down here we have 1/8. Over here the 8 was on top. So whenever you have a negative exponent, all you have to do is change the position of where it's at. So let me kind of put that into words here. Let me put that into words. Uh, Negative exponent, since we were there. If you ever have a negative exponent, you're basically going to switch the position of where it's at. What I mean by that is there's always this line that runs across, right? There's always that line that runs across. Even if you have a nice number of something like the number 5, there's always the line underneath it, and it's 5/1. We can always turn a number into a fraction, right, if we don't see it. So imagine you guys have something like x to the -5th power, and I told you guys that I hate that negative. Well, let me kind of make this a fraction real quick. I'm going to write the line underneath it, and I'm going to go ahead and just leave it like that for a minute. What you want to do is, in order to fix a negative exponent, you have to move this entire piece to the opposite side of that line. So I'm going to drag this all the way down, all of this down, and then that's how it turns now into a +5. Now, well, you're like, well, what do I put up here? Well, what do we normally put as just like as a placeholder? What says that there's something there? Well, we're just going to go ahead and put the number 1. Okay, so notice originally it was x to the -5th power, but again, we fixed that negative exponent by moving everything down to the bottom, or at least that section of it down to the bottom. Now, what if you have a fraction like this? What if you have 1/x to the -4th? And again, I still have an issue. I don't like that negative exponent. So how do I fix that negative exponent? Well, we're going to move this. Guess where we're going to move it? It's at the bottom. It's in my denominator, so we're going to kick it up to the very top. This x to the -4th is going to move to the top, and now it's going to become a +4. What do you want to put at the very bottom? You can go ahead and put a 1 if you really, really wanted to, but x to the 4th over 1 is still the same thing as x to the 4th. All right, so all you're really doing, guys, is you're jumping back and forth, top and bottom on your numerator and denominator. You're literally dragging things from the top to the bottom or from the bottom to the top of that line, right, in order to fix a negative exponent. That's all you have to do. So again, don't overthink that one. You're just literally shifting its position. All right, what about 0 exponents one more time? Anything to the 0 power, guys, will always be 1. If you had 100 to the 0 power, that's still going to be 1. If you have x to the 0 power, that is still going to be 1. You just have to be careful, who does that 0 actually belong to? So let's jump into a couple of examples here. So 0 power, since we kind of were already talking about that, take a look at example 1. You have t to the 0 power. Anything to the 0 power is going to be 1. Be careful. What do you think is the most common mistake? Students see 0 and they automatically want to give me 0 as an answer. No. Whenever you have a power of 0, your answer is going to be 1. Now, this 0, let me just kind of emphasize this. This 0 belongs to the t. So watch out for that. Watch out for that. You have to make sure you know who does that exponent belong to. And so because this 0 belongs to the t, that t is going to turn into a 1. All right. Now take a look at the next one here. You have 0. Who does that 0 belong to? Does it just belong to the x? Does it just belong to the 4? Does it belong to both of them? It actually belongs to everything inside of those parentheses. It belongs to both the x and the 4. And again, you're not multiplying like 4 times 0 or x times 0. No. 4 to the 0 power, x to the 0 power. What do we say anything to the 0 power was going to be? It is going to be 1. And again, be careful here. This 0 actually belongs to both of them. That's why both of them turn into just a giant 1. For number 3, this is where it starts to get a little bit tricky. Who does that 0 belong to? It says w to the 0 power divided by 7. This 0 does not belong to the 7. It only belongs to this w. So this little section here, what's w to the 0 power? What's anything to the 0 power? That is going to be 1. Can I do anything with the 7? Nope. I'm just going to drag it over. This is now 1 over 7. So again, just because you see a 0 doesn't mean your answer will always be 1. That section, that piece, is what's going to turn into a 1. Take a look at the 4th one down here. 4x to the 0 power. It looks very similar to number 2, but who does the 0 belong to now? Doesn't belong to both of them. This is 0 because it's not in parentheses. This 0 only belongs to what's immediately to the left in front of it, which is just the x. So only this section right here, that's what's going to turn into what's x to the 0 power. That's what turns into a 1. Let me bring down my 4. What are we going to do with the 4 and the 1? Because that's not 41. This is 4 times 1, which is just going to be 4. Please be careful with these two. I would put stars next to these. Guaranteed to show up on future assignments, future tests. because we want to test you guys. Do you understand who does the exponent belong to? All right, so careful with that. All right, negative exponents, guys. So take a look. We hate negative exponents. We have to change their position. So take a look at the first one. 3 to the negative second power. Right now, it doesn't look like a fraction, but if I wanted to, I would draw the line underneath the 3. Right? I would draw the line underneath the 3. I'm going to go ahead and draw the line on the other side of the equal sign. Right now, this negative 2, this 3 to the negative second power, where is it sitting? It's sitting on top. Remember, all you have to do is switch it from the top to the bottom or from the bottom to the top. Well, if it's sitting at the top, we're going to grab it, we're going to move it to the bottom, and immediately it turns into a positive exponent now. What do we put up top just as a placeholder here? We're going to go ahead and put a 1. There's a 1 there if we don't see it. This is now 1 over 3 to the second power. We could actually multiply that. 3 to the second power would give us 9. The more appropriate way to write this would actually be 1 over 9. Okay, but I'll take that. If you can get to that point, that's kind of the big leap for today. All right, take a look at the next one. This one's already a fraction, but again, take a look. 4 to the negative second. Where's that sitting? It's sitting in the denominator. How do we fix that? Well, we're going to grab that and we're going to toss it to the top. This is now going to be 4 to the positive second up above. Now down here, you can just go ahead and put a placeholder. It's just going to be a 1. And please be careful. You're not flipping the fraction. You're not flipping. You're just moving sections of it. You're moving parts of the problem. So please do not think of this as you're flipping the entire fraction. No, don't do that, please. So this is technically your answer. We could take it a step further. What's 4 to the second power? That means 4 times 4. 4 times 4 is 16 over 1. What's 16 over 1? 16 divided by 1 is just 16. All right, here's a couple more with negative exponents. If you want to take a minute, pause the video, try it out, and when you're ready for the solutions, go ahead and hit play. All right, example 1, 4 to the negative second. Again, if I make this into a fraction, that's sitting on top of my numerator, so I'm going to go ahead and drag this down to the bottom to turn that into a positive 2. And again, up above, I'm just going to go ahead and put a 1 as a placeholder. We can take this actually a step further. The 1 doesn't change, but what is 4 to the second power? Again, that denominator, what's 4 to the second? That's not 4 times 2, that's 4 times 4, which is 16. There we have it. All right, take a look at number 2. Take a look at number 2. Here, I see that I have a negative exponent. It's in the denominator, and that a to the negative 4, we're going to go ahead and kick it to the very top. So this moves to the top. It turns into a positive 4. Down below, I could put a placeholder of a 1. It looks tacky, guys. A to the 4th power divided by 1. It's just going to be a to the 4th power. It's kind of like saying 5 over 1. It's the same thing as saying 5. Nobody writes 5 over 1. We just go ahead and write 5. All right, for number 3. And again, be careful with this one. I don't want you guys to use the word flip. You're moving its position, all right? So x to the negative 4th. So I see this right now, and I'm like, that's wrong. I have a negative exponent. It's sitting up above that x to the negative 4th. I'm going to go ahead and kick it down to the bottom. X to the now positive 4. All right, and I also realized that, hey, there's a y with the negative 3 power, and that's in my denominator, so I'm actually going to have to kick that 1 up to the top. That's going to turn into y to the positive 3rd up above. And again, yes, it looks like the fraction flipped, but please be careful. Don't use that word. Do not use that word. They will not always interchange like that. Hopefully we see that with number 4 here. So take a look at number 4. I'm putting 2 problems in one. We're going to have to use quotient of powers, and then I'll show you guys how to fix it. So if you remember from the last couple of examples here, what happens if I'm dividing and I have the same bases m and n? I can subtract those, right? What is 5 minus 8? That gives us negative 3. This is going to say right now m to the negative 3rd power. And remember, I said I hated that negative exponent, so I'm going to show you guys how to fix that here in a second. But let's do the other part of this problem. What am I going to do over here with the n's? Well, same thing. We're dividing. We have the same base, n and n, so we're going to subtract the top exponent minus the bottom one. 6 minus 4, this time it's a positive 2, so we're going to end up with n to the positive 2nd power. Even though we did apply quotient of powers correctly, this is still wrong because it's not wrong, but we don't like to have that negative exponent. And again, if we want to turn this into a fraction, let me draw that line underneath it. Equals. What's going to move? not the whole thing. The fraction doesn't flip, right? Be careful on what you're moving. Which one has the negative exponent? It's just the m. That's the only one that has to get kicked out. That's going to move to the bottom and turn into a positive 3. What about the n to the second power? It was positive. I don't have to move it. We're going to leave them up above. We're going to go ahead and leave them up above. And that is our final answer. So that's how you fix negative exponents, guys. Just go ahead and move their spot. Go ahead and move their spot. All right, guys, here is your class activity. Here's your class activity. Careful on these last two. Who does the 0 belong to? Who does the 0 belong to, okay? So just like the previous days, guys, go ahead and do this work on a separate piece of paper. When you're done, check your answers with my sub. They should have the answer key. If everything's perfect, go ahead and turn it into the inbox. All right, guys, take care. Have a great day.